Hi everyone, my name is Teng Liang. I'm a PhD student at the University of Beichuan. Today I'm going to introduce my paper, Enabling off-the-grid communication for existing applications, a case study of email access. Nowadays, most people travel by plane a lot. So imagine that you are at an airport and you use your smartphone to download all the emails on your phone before you boarding on plane. Later, when the flight is taking off and you want to work on those new emails on your laptop, however, there's no internet connectivity, so laptop cannot reach the client, the cloud server, so the email application cannot download those emails. In fact, the emails is stored on your phone, and there's local connectivity between your laptop and between your laptop and the phone. However, the email client, the email application is not smart enough to communicate with each other. So email access is just one of many today's applications which require internet connection and rely on cloud service to be functional. However, such internet connectivity may not be available in many scenarios, such as on cruise, you are hiking, when you are listening to concert music outdoor, or traveling or driving on the highway, or during a disaster. So the existing solution, there are few existing solutions, such as the AirDrop, which enables the transfer of files among Mac OS and iOS using Wi-Fi or Bluetooth. But the problem is, this is ad hoc and application-specific service. It's only available for Apple devices, and you do not know how to apply this to other applications. So we think to enable an application to achieve app-to-app communication, there are 3 must steps. So the first one, we have to enable an application to discover data in a local network. And second, the application should be able to retrieve those data. And last, the application should be able to verify the data. Because currently, the application always talk to a trust server. So the data is downloaded on the trust server, they may not, but in this local environment, the data may be fetched from here or somewhere you don't know, so you have to verify the data. And we believe that NDN is a good fit in this scenario because NDN assists the application to achieve these abilities. So our idea is to NDNize existing IP applications. There are a bunch of native NDN applications such as mHealth, ChronoChat, and others. So compared to these native NDN applications, which built from scratch, we think NDNizing existing applications, on one hand, these applications still possess the IP functionalities, so they can still talk to a server in IP infrastructure. On the other hand, it also saves the efforts to develop those non-network modules, such as user interface UI and application logics. And this will take a lot of effort and doesn't actually belong to the network part. So in this paper, we actually take the email access as an example. We study a very simple, standardized protocol, and we propose MailSync. Our ideal goal is we want to generalize several mechanisms to apply to every application. But in this paper, we just take the email as a study case. So here I will start to introduce the details. But this one, I first introduce the high-level idea of how the MailSync works. So the MailSync, as you can see, is installed. On the phone, I will use the initial example I described. So you download the emails on the phone. As you can see, the MailSync is installed with the email client. And from the email client's point of view, it still uses the IMAP, which is the standardized protocol to access emails. So the email client will, the MailSync is transparent to the email client. But the email client will talk to the MailSync, and the MailSync will forward the IMAP to an IMAP server if it chooses the IP networks. So in this case, the MailSync basically acts as a proxy in the middle. However, it does more than that. So in our design, when the email client uses the IP servers to fetch emails, the MailSync will translate the responses into NDN data. because we want to serve these emails later in an NDN network. In order to do that, you have to translate them into NDN data before they can be served. So later, when we translate those data on the phone, so right now on the phone we have emails, and they are stored in NDN data. So now you want to use your laptop to access this data. So again, on the laptop, you have MailSync installed together with the email client. The email client still uses IMAP to access emails. But the IMAP traffic will go through the MailSync. At this time, there's no IP networks. The MailSync will translate those IMAP commands into NDN interests and send it to a local NDN network. The network will handle it, find the peer which has the data, and so which is the peer MailSync on the phone, and fetch the data line. So at this step, you can see the MailSync will do the translation from IMAP command to NDN interests. So after the interest find the data will be sent back all the way to the MailSync on the laptop, and the laptop will translate the NDN data into IMAP responses and send it back, because the mail client only understands that. So let's put everything together. This is a whole picture of how it looks like. We have MailSync on both the phone and IMAP, which will convert the email client's IMAP requests into NDN and also IP. So the email client will send IMAP to the MailSync, and the MailSync can decide which way to go. You can either go to the IP network, IP TCP networks, or using an NDN networks. So by default, we use IP TCP networks, but there can be different strategies applied. So to achieve what I just described, those functionalities, this figure contains the major components. The first one is network selector, which just selects which network to use, and the IMAP handler, which is responsible to talk with the email client. And the main module is this NDN module, which carries the core functionalities when we do the protocol translation, when we do the security management, and the NDN data translation. I will introduce all these parts later in the following slides. So the first big one is NDN data translation. So here we apply one of the most important principles, which is application layer framing. This principle was actually proposed like tens of years ago in a paper. And we will talk about the namespace design accordingly. So here in this slide, the IMAP, this picture shows how data actually is organized in IMAP. So in IMAP, you have a user. Under the user, you may have multiple mailboxes. In each mailbox, you have many messages. Each message may have attributes, text. So as you can see, on the right side is an example. That's my email address, and my mailbox. There are many different messages. So however, the current TCP IP network, it does not apply application layer framing, which means they do not define application layer units. As a result, they may make a request like this. So what does this mean? This actually means the client wants to fetch the attributes to message 1 to 4. So they can make random query on a subset of data sets. And the server, when the server receives this request, it will make the process that on the database and get the results. And when the server sends back, it will send to a TCP socket, which is just a string. There's no application layer boundary. But when we want to serve those in NDN, we want to define NDN application data units. Actually, the data structure in IMAP is very close to how people treat the data. We can easily map them into NDN hierarchy. But here, we have to review how they are organized. For example, in the message attributes, there are two types of attributes. The first type belongs to the mailbox, which can update them, such as the flag. So basically, you can mark your email read or unread. This is the flag of the message. And this is controlled by the mailbox. So different mailbox, you can set different flag to whether it's important, it's read or not. There are second type of attributes which belongs to the message itself, which I call metadata, like the size of the message, the structure of the message. These are immutable. When the message is produced, this data should be produced together with the message. So when we translate, I split these attributes into two attributes. One is I call status, the other one is metadata. So the reason I do that is because the mailbox may need to change the status, like the flag, but it should not change the metadata, like the size of the message. That should be changed by, that should be defined by the producer. So in NDN, the data, the first thing is to define those data application units. You only can access and retrieve, like consume the data by the units. And on the outside, that's the namespace design. Basically, it follows the structure of IMAP. We could actually totally define a totally new one, but because we want to use our translation procedure, we use its organization. I will talk about later.
Can you comment on the mailbox version? So what is that version for?
On the mailbox version?
Yeah.
So in reality, in practice, we implement it. Normally, there's only one version, but in the protocol, in the IMAP protocol, one mailbox may have different version because of the server, how it's stored, how it organizes the real data. So it may somehow construct a new version of mailbox. So they reorganize the sequences of messages in the mailbox. So in the protocol, they have a version of the mailbox. So if you want to identify a mass email uniquely in the server, it is identified by the mailbox, the version, and the ID.
I thought message ID is actually unique. No?
In IMAP, it's not. They have these three.
So that version is IMAP version.
The version is IMAP version. It's not how we add a link. It's just we want to adapt to. So as a result, you can see for these requests in IP and IMAP, we have to in NDN, we have these application data units. We actually define them as data that are produced in advance, and they have to be fetched in advance. So you cannot, in NDN, you cannot just send a random query to ask for stuff. You have to send exactly, that may not be exactly, but in this case, we have to ask for application data units. So that's so I just introduced how we do the NDN data translation. The second thing is the protocol translation. So here in IMAP basically is a synchronization between the client and server, two parties. The basic steps is you connect to an IMAP server. There may be TLS, SSL stuff, and then the client has to be authenticated by the server. So after that, you select a mailbox. Basically, you get the client asks the server what's in the mailbox. The server will give send a snapshot back to say here are 10,000 messages and some metadata about these messages. So after you retrieve the status in your mailbox, you are able to identify the difference between your current status and the version on the server side. So you actually can ask for the difference. So basically, you can have the 40 fetch messages to get the different, the new emails. To translate that into NDN, basically preserve its logics of fetching emails, except we'll actually communicate to an NDN network instead of an IMAP server. So in NDN, we don't need to connect to a specific server. And we don't need to do authentication because for each interest, each data, we put the security into it. So actually, we translate start mainly from this step. So when you fetch the snapshot of a mailbox, which use the select command, that's an IMAP command. When you translate it here, that's the initial interest, which follows the namespace design, and using this /mail sync / your email address / inbox / select. So this interest will be marked, must be fresh. So it should not be consumed by the by the cache data. So it will definitely reach the peer mail sync. And the peer mail sync will process it and return the latest version of snapshot that, which contains also the message names. In this case, it only contains the message UID and the version. So the other side is able to construct the exact name for those data. So after that, the mail sync is able to fetch the data. So in Ambient, the data discovery part, the essential part of data discovery is to discover the names. When you figure out the exact names, you are able to retrieve those data in Ambient. So next.
Can I, if you don't mind asking questions? So I'm not sure why you used word select, because if I remember in IMAP protocol, select is to select something and then you do list to get to select is for the session, but then you do list, so this technically is list, not select. Because
so you select the mailbox, so we can do everything.
But you don't do select mailbox, you do list of the mailbox. I mean, based on the sub-bullet B. I mean, there's nothing to, I mean, select is something for the session. There is no session to select, so you...
No. Select, you select the mailbox. So you do
for
every
the
operation
session.
under this mailbox.
But it's again, it says IMAP's notion of session is selected.
But this select, it will also return the status of the mailbox back.
Which is list.
Yeah, which is, I mean, first we only consider the read operations. And there are many read operations that overlap functionalities, like the list, what you just said, right? So the select will return what list will return in this case.
Then why is it not list? Anyway, so that's one question, and the other one, so you're saying that there is no authentication of this interest, so you don't use command interest?
Well, we use command interest, we introduce that in the security part.
But this one, so yeah, I think you're saying you will change this interest to command interest, or you use command interest
well,
somewhere else?
We will assign this interest. I will introduce in the later part. So integrity. So here is what we consider for the security. So integrity, all the interest in data in our work assigned. So the interest, as Alex mentioned, this one will be signed. So the other part knows who actually issued this interest. And for our trust model, in the paper we described, we assume each device is signed the mail-sync's key, and each device, the owner's key will sign the device key, so we share the trust anchor. But actually, in our real design, they don't have to share the trust anchor. They can have very ad hoc trust between two parties. So there are some user interactions to trust each other. And the third point, content confidentiality and access control. So in IMAP, the access control is achieved with authentication. You have to be authenticated first by a server, then you are able to retrieve the data. But in NDN, you can retrieve the data from anywhere, from peer, from cache. So we have to ensure the access control by encryption. So we use encryption to achieve access control, which means the two parties in our scenario will share a secret symmetric key to encrypt the data. And the last consideration is name obfuscation, which is for privacy purpose. So because the encryption is only for data content, but the names are not protected. Sometimes in the names there are sensitive information such as the username you may not want to expose to the network. So we also use the symmetric key to encrypt those named components. And as you can see for these considerations, there are two important parts. The first one is they have to trust each other's certificates, how to do that. The second one is how do we synchronize a symmetric secret key between the two parties. So we use a Bootstrap procedure to achieve the first thing, set up trust. The second thing, synchronize the secret symmetric key. So this is the Bootstrap procedure. One of the device will send bootstrapping interest to the other side, which is a command with sign, and the other side will return a packet, which is also signed. So by this step, it's actually triggering it to fetch the certificates, the chain of certificates. And there may be some user interactions to trust the other side. So this can be done on my phone or on my laptop. I want to scan what's in the network, and discover there's a phone that carries my data. And you may just say, I trust this phone. And on the other side, you also need to do similar operations. So you basically trust the certificate to sign those data. And the naming schema can be applied here. So after that, you are able to exchange the secret symmetric key. Because this is a public channel, you may want to encrypt those secret symmetric key. So we use, after the first step, you actually have the certificate. For example, the laptop has the certificate for the phone, which means you have the public key of the phone. So you can encrypt the key of the phone, and in the naming, you explicitly point them, just like similar to the name-based access control. Then you are able to send the encrypted secret symmetric key to the other side, and the other side can decrypt it by its private key. So after that, you are sharing this secret symmetric key. So currently, we have implemented the mail sync in Java, and we support it to Android. So we have a demo to show the laptop can communicate with your phone to fetch emails from your phone. And we have some students to work on it to build full feature, so we can release it sometime in the future. And okay, this is so. To summarize, we only consider email access in this paper. We only consider read operations. We want to do very basic study, and this is specific for IMAP. We could not currently apply it to other applications, but we are doing XMPP, which we have basic designs already. So our ideal goal is we can generalize some problems when we analyze existing applications and propose some generalized mechanisms. So this is about this paper. Any questions?
I have two questions. The first one is that this is only one-to-one patching.
Yeah.
Can you use that to handle mailing lists? That is, 3 people on the same mailing list. Can you extend this to handle that?
So you mean you subscribe to a mailing list, you have an email in your client, on the client. So supposedly because this is your client, so only your device should be able to synchronize them.
I want to generalize this so that we can actually support the email application like say email.
So you want to send email to a mailing list?
That's my second question.
Okay.
Here, only 3 questions will use support send email. But the first question is to say, now you only retrieve from one command. My question is, if this were a mailing list, can I have 3 commands retrieve and still enjoy the use of multi-custom delivery?
First, this cannot, because we preserve the IMAP semantics. IMAP basically does synchronization between 2 parties, the client and server. And the good thing about NDN is we can do multi-party synchronization using NDN sync. This is actually what we figure out when we're doing XMPP. So this one only covers 2 parties. When it involves multiple parties, we have to use NDN sync to synchronize between multiple parties. So I think what you described is visible using NDN sync. In the current work, it cannot be achieved.
So about sending message, I think you mentioned about supporting SMTP. Will you be able to support transit as well? Like you talk about real problems, that's exactly what I have. So when you first download on the airplane, you finish all the replies, but as soon as you landed, you want them to get out before you actually approach the terminal.
Yeah.
So you wish you could send back to the phone, and the phone, as soon as you landed, you can turn on the phone and
So for this, we won't consider IMAP, which only, and also the read only. So it does not support the SMTP, but it is very feasible with our following work. Because if you use NDN sync, you can synchronize the data sets among multiple parties. And so it does not matter who generates data, because when you generate data, you actually create data on the namespace. If you synchronize that namespace, the data will be synchronized on the phone.
I do not know how the phone, or the iMac on your phone handles the transmission, sending packets, sending it. I mean, your I should say, your email client on the phone, how that can accept the email replies produced by your laptop. And get that one, and when you have separate connectivity, then the phone can send. Maybe we'll take it offline.
Yeah, but I think this is feasible because if you look at the design, the MailSync will handle all the things. So it may not be the email client, but the MailSync will, on behalf of the client, to send out the emails to the server. But again, we didn't do SMTP, so I'm not sure the details, but that could be a future requirement. We do consider the right operations later.
My understanding of iMac is only receiving messages.
Yes.
So transmission still is SMTP.
I mean, so there is a mode in IMAP to write into the mailbox, so you can reorganize your emails, or not just read them, but rather put in the other mailbox, or put something in the mailbox. But everything is about the mailbox, not sending mails out.
But the iMac doesn't have an outgoing mailbox, does it?
No.
No,
So I mean, there is a right thing in the IMAP, but it's not about sending mail, but rather organizing your own mailbox. And for SMTP, I don't know exactly how it can be organized, because with the IMAP, it's a data set that you're trying to synchronize and keep on replicated in different places. With SMTP, you want to send out. I mean, you want to send out once, not replicate and send multiple times. So that's also quite challenging. Because the case that Lisha just mentioned is that I work on one computer, then decided to the other computer has a connectivity, so you want that computer to send messages, but you at the same time don't really want to send those messages again. But the other computer is now this kind of not talking to each other, so it may try to do the same thing again. So there are challenges for SMTP in here. We have a few more minutes to have a discussion.
That's all the question.
Yeah, so going off of the question that you shared about mailing list, would augmenting your MailSync layer or the module that you have to differentiate between when it gets the IMAP commands from the internet, would differentiating what mailing list messages are being pulled and using your MailSync client to become a producer for those, so it advertises itself as a producer for that mailing list. Would it help, do you think, for being able to sync on NDN layer for mailing list? So I'm on a plane and somebody else is a producer for that mailing list, I might be able to get more updated emails, do you think?
If we take the current namespace design, you cannot produce them because it's all under your namespace, right? Okay. If you want to produce them, they should have a separate namespace. We didn't consider that in this paper, but if we have a different namespace like the mailings, that's what I actually mentioned. We could take a totally different namespace design, but accordingly, we should have those
naming convention.
Yeah. Mechanism to support it. Question?
What kind of same-chip encryption are you also use?
Sorry, what?
You say you do the encryption?
Yeah.
Use the same chip.
Yeah.
What type of one
What type? We just
So you use AES or what type of algorithm?
yeah, we will use AES.
Use AES.
Yeah, AES.
My second question is, you also use a peer-based, peer-to-peer trust, right, to do the authentication?
What we don't do, I mean, authentication is built in with those traffic. You sign the interest, and when the other side, they can verify if this is signed, and if they trust your certificate, they will trust the whole thing.
So just one-time authentication between two different devices?
No, this is an MDN. Every piece of data is signed individually.
Oh, okay. So that, which means there's a lot of overhead, right?
Well, in IP, you use TLS. You also encrypt all the things, right? You have to decrypt them. That's also overhead, right? I mean, if you encrypt something, you always have the overhead of encryption and decryption, no matter at which layer. So I assume in this scenario, you always have to encrypt the data.
So you actually use IPv6?
We don't
We don't
care.
really care. Anything that can carry a packet.
Yeah, we don't care the lower layer stuff.
It could be IPv6, IPv4, or could be just Ethernet frame if it exists. Anything.
Yeah, I'm just thinking about every piece of data you download, you have to do the encryption, so that's...
Yes, because in NDN, data can be cached anywhere. So the lower layer you may send from IPv4, IPv6, even Bluetooth, whatever. Unless it's an NDN packet, when it gives to me it's an NDN packet, we can utilize that data. So we have to encrypt those things.
Okay, thank you.
Thank